This is what a completed bill of materials looks like. Every component, every part number, every quantity, all in one organized document. And every single industrial control panel that has ever been built started with a document exactly like this one. A wiring diagram tells you how to build the panel. A BOM tells you what to buy to build it. And without a BOM, nothing gets ordered, nothing gets built, and nothing gets shipped to the customer. In this video, I'm going to show you what a professional BOM looks like, walk you through every column and why it matters, and then build one from scratch together using the spec we covered in Episode 4. Welcome back to Panel Design Pro. A bill of materials, or BOM, is a complete list of every component needed to build a control panel. Every wire, every terminal block, every contactor, every push button, every piece of DIN rail, it all goes on the BOM. The BOM is one of the most important documents a panel designer produces because it drives three critical things. Purchasing. The BOM tells the purchasing department exactly what to order. Budgeting. The BOM with pricing attached tells the customer what the panel is going to cost. And build quality. A complete and accurate BOM means the panel builder has everything they need before they start building. An incomplete BOM means the build stops while someone goes hunting for missing parts. The BOM gets used by almost everyone involved in the project. The designer creates it. Purchasing uses it to order parts. The panel builder uses it to verify parts on receipt and during assembly. The project manager uses it to track costs. And the customer uses it to understand what they're paying for. Let's look at a completed professional BOM and walk through every column. The first column is the item number. This is just a sequential number, 1, 2, 3, 4, that gives every line item a unique reference. When someone says check item 7 on the BOM, everyone knows exactly what they're talking about. The second column is the quantity. How many of this component do you need? One main disconnect, 3 push buttons, 24 terminal blocks. This is where mistakes get expensive. Order the wrong quantity and you're either waiting for parts or throwing money away on excess stock. The third column is the manufacturer. Who makes this component? Allen Bradley, Phoenix Contact, Eaton, Schneider Electric. The manufacturer is important because components from different manufacturers are not always interchangeable, even if they look the same. The fourth column is the part number. This is the exact catalog number for the component. Not just a contactor, the specific model, current rating, coil voltage, and configuration. The part number eliminates all ambiguity. Anyone in the world can look up that part number and know exactly what to order. The fifth column is the description, a plain English description of what the component is and what it does. Motor contactor, 3-pole, 9-amp, 24-volt DC coil, for example. This helps non-technical people like purchasing staff understand what they're ordering. The sixth column is the unit cost. What does one of these components cost? This column turns your BOM into a budget document. The seventh column is the extended cost, quantity times unit cost. This is what you actually pay for this line item. And the final row at the bottom is the total, the sum of all extended costs. This is your panel's material cost. Now let's build one from scratch. We're going to use the simple spec from Episode 4 as our starting point. Here's what we need to build. A basic motor starter panel with a start button, stop button, e-stop, 110 horsepower, 480-volt 3-phase motor output, a run light, a fault light, and a 24-volt DC control circuit. The first thing I do when starting a BOM is go through the spec section by section and list every component I can identify. Don't worry about part numbers yet. Just get everything on the list first. Starting with the power components. I need a main disconnect, a circuit breaker sized for the incoming power and the motor load. For a 10 horsepower 480-volt motor, I need a disconnect rated for at least 30 amps. I need a motor contactor sized for 10 horsepower at 480 volts. That's approximately a 9 to 18 amp contactor depending on the exact motor FLA. And I need an overload relay to protect the motor, sized to match the motor's full load amp rating. Next, the control components. I need a 24-volt DC power supply to power my control circuit. I need 3 push buttons, 1 start, 1 stop, and 1 e-stop. I need a safety relay for the e-stop circuit. I need 2 pilot lights, 1 green for run and 1 red for fault. And I need terminal blocks for all my field wiring connections. I'll estimate 24 terminal blocks for this panel. Then the infrastructure components. These are the things that hold everything together inside the panel. DIN rail for mounting components. Wire duct to organize and protect the wiring. The enclosure itself, rated NEMA 4 for this application. A back panel, the steel plate inside the enclosure that everything mounts to, and miscellaneous hardware, screws, labels, wire ferrules, and cable ties. Now I fill in the part. Numbers, quantities, and costs for each item. I look up each component on the manufacturer's website or distributor catalog, places like Automation Direct, Allied Electronics, or Grainger. I enter the exact catalog number, the unit cost, and calculate the extended cost. Once every line is filled in, I total the extended costs at the bottom. That total is my panel's material cost. I'll typically add a markup percentage on top of that for overhead and profit before presenting it to the customer. Before we wrap up, let me share a few tips that will save you time and headaches when building BOMs. Tip 1. Always include spare parts. Add a line item for spare fuses, spare terminal blocks, and spare push-button contacts. Panels get installed in the field and things break. Having spares on site saves a service call. Tip 2. Check lead times before finalizing. Some components, especially PLCs, certain contactors, and specialty enclosures, can have lead times of weeks or even months. If you build a BOM without checking lead times, you might find out the panel can't be built on schedule because a critical component is back-ordered. Tip 3. Use a spreadsheet template. Build yourself a standard BOM template in Excel with all your columns already set up and formulas already written for extended cost and totals. Every new project starts from that template. It saves time and keeps your BOMs consistent. Tip 4. Version control your BOM. Every time you make a significant change to the BOM, update the revision number and date at the top of the document. BOMs change constantly as projects evolve. Version control means everyone is always working from the latest version. Let's recap what you learned today. A bill of materials is a complete list of every component needed to build a control panel. A professional BOM includes item numbers, quantities, manufacturer, part number, description, unit cost, and extended cost. You build a BOM by going through the spec section by section and identifying every component. Infrastructure components like DIN rail, wire duct, and enclosures are just as important as the electrical components. And always check lead times, include spares, use a template, and version control your documents. The BOM is your first real panel design deliverable. Master this document and you're thinking like a professional panel designer. In the next video, we're going to take our BOM and start turning it into a real schematic drawing in AutoCAD Electrical. That's where the design really starts to come to life. If this video helped you, hit subscribe and drop a comment below. I'd love to know what type of panel you're designing or what industry you're working in. I'll see you in the next one.